Hello everyone. Welcome back to the course of data structures using C language. This video is brought to you by Newton's Group of Institutions, Macharla. This is Aravind Yegireddy from the Department of Computer Science and Engineering. Till now, theoretically, we have discussed about how to append a node, how to add a node at the beginning, and how to insert a node at a specified location. And we have discussed how to delete the node from the beginning, from the specified location, and from the end. Then we have also seen the logic for how to find the length of a linked list and how to display the elements in the linked list. Now, let us see the single linked list execution with all operations using the C programming syntax. First, we have to include the header file stdio.h. So hash include stdio.h. We know that single linked list is created by using dynamic memory allocation. So we need to include stdlib.h because we are going to create the nodes dynamically by using the malloc function. And here we will be using free function. So we have to include stdlib.h header file. Next, in the main function, inside we need to print what all the operations what we are performing that we have to display. So inside the main, the first statement what we are displaying is single linked list operations. Then the first operation what we perform is an append operation. And the second operation is add a node at the beginning of the linked list. Third operation, adding a node after a specified location. And the fourth, to find the length of the linked list. And the fifth operation, to display the elements from beginning to end in a linked list. And the sixth, deleting a node in an linked list. And finally, we use the quit operation to quit the program. So here it is first we are asking enter your choice. So we have to enter the choice, and whatever the choice we enter, that we have to collect using the scanf functions. Scanf %d &ch. So into the address of the variable ch, we are reading the value. So now here in the main method, we have to declare ch, which is an integer type variable. Okay, so here it is only one operation will get executed for one time if you are writing the logic like this. And we have seen this particular approach in stacks and queue implementation, that is for continuously to perform all these operations. How to write the logic? Simply here, all these things we need to place in the while loop. And in the while loop, we are using the condition as 1. That is while of 1, which means which is always true. So this particular loop will get executed infinite number of times. And to make this logic work perfectly, what we need to do is we need to use the switch case. We need to use the switch case. So depending on the switch case, all these 7 cases we have to write. So in case 1, we see how to add the node at the end. That is, we simply call the append function. And we know that after every switch case, we need to write the break. And the next, that is case 2, we need to add at begin. And After that, we need to, of course, we have to use the break statement. And the third case, we see add it after, that is to add the node at a specified location followed by break. Next case, for length function to find the length of the linked list, next break. And case 5 to display the elements, then break. And the sixth one is deletion, deleting a node from the linked list, fail. And the last case is case 7, that is quit from the program. So for the quitting the program, we are using an exit function, which is an predefined function which resides in stdlib.h header file, which we have already included at the starting of the program. So here the exit is having an argument. So here in this case it is 0, but you can have either the value 0 or 1. 0 means abnormal exit, 1 means normal exit. Now, if we enter other than one of the 7, then we know that what we have to do. We have to execute the default case. So we are in the default case, we are going to print a invalid input. So depending on these functions, we are calling all these things and get executed. Now let us write the logic for all these functions. So first let us write the logic for the append function. Okay, first we are going to write the append function, void append. So to perform all the operations of the linked list, we have to first define the structure as a global variable. We have to define the structure as a global variable. Can anyone say why we have to define the structure as a global variable? Because we are going to use this structure in all the functions. So we have to declare the structure node, and after that we have to put a semicolon. So struct node should end with an semicolon. And here we have one field, that is a data field, which is of type integer type. Next we have to use the link field, which is of struct node pointer type. Why we are using the link field as struct node type? Because the link is going to hold the address of an other structure node. That's why the link field, the type of the link field is struct node type. Okay, so here globally we have to declare one variable which is a root variable. Now what is the initial value of this particular root variable? Though we are not initializing the root variable, all the global variables in the C language, they initiate with the value null. So here the initial value of the root variable will be equal to null. Now the node is ready and the root variable is also ready. Now parallelly let us write the structure so that we can easily understand and write the logic. So now here the root variable is created and it is created with the initial value as null. Now we need to create the node. So how to create the node? So now inside the append function, whenever we call the append function, first we need to declare one temporary variable which is an local variable, because we know that any operation in the linked list we have to perform using the temporary variable only. So here we declare struct node pointer temp. So temp is a temporary variable which is a local variable whose initial value will be the garbage value. See, the root variable we have declared globally. So the root variable initial value will be null, whereas here the temp variable what we are creating is a temporary variable and which is a local variable. So the initial value will be the garbage value. So now the temp gets some memory allocated at some location. Okay, Now, how to allocate value into this temp? So for that, what we do is we use malloc function. So malloc size of struct node. So now what the malloc function will do? It means it will create the node. That is nothing but the memory will be allocated with the two fields, say at some location 2046. So it will create a node. Now this is the node what we have to create it. Now what I want to do? I want to store it inside the temp variable. So the temp should point to this particular newly created node. So for that, the temp is equal to struct node pointer malloc of size of struct node. Since the malloc return type is void, which is a generic pointer, so we are typecasting. So here we are implicitly converting it into struct node pointer type, because we know that the temp variable, the type is struct node pointer type. So here what we are doing, malloc function, the return type is void. We have already discussed this particular thing in dynamic memory allocation in C programming concept. So here we are implicitly converting that value and we are assigning it into temp. So here now the temp will get the value 2046. So the temp will be pointing to this particular node. So after the creation, now we need to read the information. So for that, what we do? Printf, enter the node data, and using the scanf function, we read the data into the node. But at which location? So we need to read the data at which location. So now temp is pointing to this particular data. So now we have to collect temp to data address, we need to collect the value. So here we need to write temp to data address. So ampersand temp to data. Now suppose the node value is given 10. And in the next location, I have to place the value null. So how to place the null value here? Temp to link is equal to null. So this is how we are going to read the information into the new node what we are creating. Now, after reading this information, what we have to do is we have to check whether where we have to connect this particular node. Either we have to connect this node to the root variable or we have to connect it to somewhere else. So if the list is already having some nodes, then we have to connect this node at the end of the list. But as of now, if you can see here, we have no nodes in the list. Since the root is pointing, the root is having the null value. So here the root should point to this particular new node. Since the root value is null, we have to assign the temp value to the root value, because the root should point to this particular address 2046. What is 2046? 2046 is temp. So here what we have to do is we have to assign the value. So here we are checking if root is equal to null. Nothing but if the node is not having any node, that is if the list is empty, then here we are writing temp value, we are assigning it into the root. So now if you see here 2046, which is assigned to the root, because the temp value is 2046, that will be assigned to 2046. So 2046 temp will be pointing to this particular node. Of course, it is the first node in the list. Now, let us see how we are going to add the other node. If, for example, if the node is not the first node, if we are already having some nodes, then we have to write our logic in the else. So using the else block, we need to write the logic to insert the new node. Suppose that we have a list which is consisting of 4 nodes like this and say that the root variable is pointing to the first location. Now, once again, we call the append function. So just we want to add one more node. So first the temp variable will be created. So temp gets some memory allocation inside and the temp value here we have garbage value in the temp. Next, we call the malloc function and create a new node and then we need to assign it into temp. So by using malloc function dynamically we are creating and that we are assigning it into temp. So now the temp gets some memory allocation inside the temp value. We have stored that value. So next what we have to do? So a node will get created and that particular location what we have seen here is 5000. So that 5000 address we have assigned to temp. Next what we are doing? We are displaying the enter the node data. So here we are collecting the data into temp to address. So here in temp to data address we will store, say suppose we have stored 35 and we are placing in the link part we are placing the null value. So here if you can see after placing the data temp to link is equal to null. So now one more node got created. So now after assigning the null value into temp to link, so we are assigning the null value. So once after assigning the null value into temp to link, we have to check whether the root is equal to null or not. So if the root is equal to null, so here it is root is not equal to null. The root value is 2046 which is not equal to null. So here the else block will get executed. So in the else block we cannot directly add. So here we have to declare one more variable which is struct node pointer type. So we are creating one more temporary variable p which is of struct node pointer type. So my p will get allocated some memory and we need to bring the p control to the last node. So to add a new node we have to bring the p control to this node, but we cannot come directly to the last node. So we have to come from the beginning. So here the p need to assign the root value. So p is equal to root. So here it is the root value is 2046. So the 2046 value is stored into p. So next what we have to do? We have to check the next node is available or not. We have to check whether the next node is available or not. And that is how many times that we have to check, that we don't know. So we have to use the while loop. So while p2 link not equal to null. p2 link not equal to null means what? There is another node in the linked list. So p is first connected to the first node. So p2 link which is not equal to null. So here we have to assign p with the p2 link value. So here we have to assign p with the p2 link value. Okay. So here in this case, what is p2 link? What is p? P value we need to assign to p2 link. What is p2 link? 5048. So that 5048 we have to assign here. So we continue like this until the p2 link value which is not equal to null. Okay, so here 5048 to link is not null, so the p value is 9042. 9042 to link is not equal to null, so the p value is 7052, and 7052 to value is null. So here when the 7052 to value is null, what we are doing? We have to exit this particular while loop. So whenever we get p2 link value null, we have to come out of the while loop. So finally, the p will be pointing to this particular last node. So now very simple, how to add? The temp value we need to store here. So here we have to store the value of temp, that is 5000, so that this node will be pointing to this particular node. So temp value we are assigning to P2 link. Okay, so here the 5000 value will be stored to P2 link, so it will be pointing here. So the fourth node is connected to the fifth node. Now let us write the code for finding out the length. After that we will see how to display, add at begin, add at after, and deletion. So now let us write the code for finding out the length of the linked list. Okay, so we have to declare one more variable globally, that is len. Now let us write the code for the length. So int len gth length. So here the length function always returns the integer type. So here we have declared one temporary variable, and we have to declare one more variable, which is a count variable. So we are declaring two variables. One is temporary variable, which is of pointer type, and one more variable, ordinary variable count, whose initial value is 0. So now the temp gets one memory allocation, and here the I also gets count also gets some memory allocated at some location, where the initial value of the count will be equal to 0. Here we should not disturb the root variable. So what all the operations perform, we have to perform by using the temporary variable only. So here what we are doing is, we are placing the root value into temp, because we should start counting the node from the first node only. Okay, so here it is the temp value we are assigning with the root value. What is the root value? 2046. So the 2046 value will be placed into the temp, so the temp will be pointing to this particular first. So suppose if the root is having null value, then there is no nodes in the list. Okay, so while temp not equal to null, suppose if it is null, it will directly return the count value. If it is not equal to null, then it is going to increment the count plus plus. Count value will be incremented. And this count is an integer type. So the return value of the function length is int. So we have written while temp not equal to null. So first we have to count plus plus. Since count is not equal to null, there is a node which is available. So the count value will become 1. So after counting the node, what we need to do? We need to send the control to the next node. That is, we need to bring this control to the second node. So how we can do that? So here, temp to link value we need to assign to temp. That is, next node address we need to store it in temp. So here the temp to link, what is it? What it is? It is 5048. So that 5048 will be stored now into the temp variable, so that the temp will be pointing to this node. Again, while loop executes as long as the temp value which is not equal to null, and it will be incrementing the count value, count plus plus, so that the temp will be pointing to the next node. So here it is the value of the count will become 2, and the temp points to the next node address, that is 5048, that is 9042. So 5048 to link is 9042. Okay, now again the count will become 3, and 9042 to address is 7052. So 7052, temp will be stored with 7052. Now again it will increment the count value, so the count will become 4, and the temp will be 7052 to link, which is null. So temp value will be stored with null. So here the condition null not equal to null fails. So it will exit the while loop and return the count value. So now in this case, what is the count value? The count value is 4. So how many nodes this list is having? 4. That is what is written here, and it will display. So here the count value is 4. So that 4 will be written and that 4 will be displayed. So whatever the value of length function returns, that we are going to we have to collect it somewhere. So that value, what we are doing, we are collecting here. So the length value that is being returned is collected here. Then we need to print the length value by using the printf command. The length of the list is %d_len. So here in the previous example, it is returning 4 and that 4 will stored into len. So that len we are printing here. Okay. Now let us see how to display all the elements in the list. So here it is, we are going to use the void display function. So all the operations we can perform using the temporary variables only. So as usual, we have to declare one temporary variable which is of struct node pointer type. And we have to display the elements again with the help of the root only. So into temp, what we have to do, we have to assign the root value. So again, here the temp value starts with 2046. So the same logic what we are using is the same logic. That is to print the length of the list, what the logic we used, the same logic we are going to use it again here. So first we are checking if the temp is equal to null or not. So what is the reason? Suppose if no nodes in the list, and if you are trying to display the elements, then no elements in the list. So directly we are printing the message saying that no elements in the list. That is, the list is empty or no nodes to display. Or else now we need to display the elements. So here if temp is equal to null, we display no elements in the list. Else what we need to do? We need to display the elements. So with the help of the while loop, so while temp not equal to null. So directly we are displaying the elements printf %d arrow. So here we need to print what? We need to print temp to data value. Okay. So now here what we have to do is we have to write temp to data. We have to write temp to data. So as long as this condition is true, the while loop gets executed. So after the temp to link value is stored into temp. So after printing the first node data, we need to go to the next node. So we need to print the node data until the next node value is equal to null. So finally, after printing, we need to go to the next line. Okay. So here we need to go to the next line. Printf \n. So this is the logic for how to display all the elements in the linked list. So we have to understand one thing. So whenever we write the functions, we need to declare its prototype above the main function. We have to declare its prototype above the main function. So here we are using the append function, which is not returning anything and it is not taking anything. So void append arguments within, right, we have to write the void. And add at begin, it is not returning anything and it is not taking anything. Next one, that is the third function, is add after, which is not returning anything and which is not taking anything. Next, length function, which is returning but which is not taking anything. Next one is a display. So the same story again for deletion and display. So deletion, it is not returning anything and it is not taking display, it is not returning anything or it is not taking anything. So now what we do, let us see the logic for void add at begin, void add at after function and the delete function. So added begin. So here in the added begin, as we know that the linked list, what all the operations we perform, we are going to perform by using the temporary variable only. So we are creating one temporary variable, and using the malloc function at runtime dynamically we are creating a node, and that we are assigning to temp, and then we are storing the values into it. So here you can see, so we have created a temporary variable using malloc function dynamically we have created, then that value we assigned it into temp. Then after that we have taken the value, and that value after that the link part we are placing it into null. So in this case here the value is being added, and here we are placing the null value, and we are checking whether the root is equal to null or not. So if the root is equal to null, so in this case the root is not equal to null, the root is equal to 2046. So in this particular case the root value is not equal to null. So what we are doing, we are temp to link is equal to root. So here if you can see, if you can understand the logic, we are placing this particular node at the beginning. So this node need to get connected to this, and this link should connect to this. So which connection first? Always right side connection first. Okay, then only we have to give left connection. So here in the temp to link value, we need to place this value 2046. What is that? That is root value. So temp to link we are placing root. Now the root should point to this node, because this is the first node what we have created now. So the newly created node is the first node. So the root we are placing the temp value. So temp value we are assigning it to into root. So this is the logic what we are going to use for adding a node at the beginning. Now let us see the logic for adding after a specified location. So adding a node after a specified location. So here also we are creating a temporary pointer variables. Here we are creating two temporary pointer variables, and we have three variables: LOC for a location where we have to insert the node, then the length function, then I is equal to 1. So we are first scanning the location value, and here we are calling the length method and assigning that value to the length. If the location value is greater than length, then we are displaying the invalid location. Else what we are doing, we are assigning the root value to the second temporary variable p. So the p will be pointing to the first node. Now we have to bring the control of the p to the specified location, because we have to insert the node after the specified location. So for that the logic is while I less than LOC, we are moving the pointer control. So p is equal to p to link, then we are incrementing the I value. So here dynamically we created a node, and that node we are assigning it into temp, and we are entering the value to the node, and then in the link part we are placing the null value. So now my node is created and my p is pointing to the specified location. So for example, in this case, if you can take, suppose if my location is 3, so I want to insert the node at this particular location. My location value is 3, so p will be pointing to this particular node. So this node what I have created, now this p to link should point to this location, and this temp to link should point to this. Which connection first means always right side connection first. So here the temp to link should be equal to what value? It should be equal to p to link value 7052. So temp to link, in this value I need to place 7052, so that the connection is established between this link and that link. So here I am writing p to link value, I am assigning it into temp to link. Then what I am doing here in this location, I am assigning this address 50. What is that? Temp. That is temp value I am assigning to p to link. So this is the logic for adding a node at a specified location. Then let us see the delete logic. So already in our previous video, we have discussed the logic for delete. So here we can delete the node from the beginning at a specified location and at the end. If the list is empty, then we cannot delete any node. So if we are trying to delete a node which is does not exist location, then we are going to enter into the if block. If the location value is 1, then we are going to use the else if block logic. And if we are going to delete the last node or a specified node, then we are going to execute this else block logic. This logic already we have discussed. So now let us see the logic. So here the program, I have written the program logic here. So here stdio.h, stdlib.h, we have created the node globally. We have created the root variable globally. We have created the length variable globally. Then we are declared the functions, the prototype of the functions what we are using. Then in the main function, we have displayed the different options operations what we are going to perform. Then we have used the switch case for making our logic work properly, and for making this logic work continuously we are using the while loop. And here for each and every operation we have append operation. The same logic I have copied and pasted: add at begin, add after, and length function logic, display logic, and delete logic. So now let us try to debug the program for the errors. So here no errors in the program. Okay, so we don't have any errors. Now let us start the program. So here operations in the single linked list: first append operation, insert a node at the begin, insert the node at any position, finding the length of the linked list, display the node from the beginning to end, delete the node from the position, and exit. So here initially there are no nodes in the list, so the length should be 0. So let us check whether what is the length. So 4. So length of the linked list is 0. Now let us, using the append operation, let us add the node. So first one, let me enter the value node 10, and again by using the append I am adding the node at the end. So let me enter the value 20. So 2 values I have entered. Next append operation, I entered the third node, say 30. Then using the append operation I entered the fourth node, say 40. So now I have inserted 4 nodes by using the append operation. So let me check the length of the list. So let me check the length. Length is 4. So here when I enter, the length of the linked list is 4. Now let me insert the node at the beginning. So let me display the elements. So using 5 option, I am displaying the elements. So 10, 20, 30, 40. So I want to insert a new node at the beginning. Say I want to insert the node 5. So for that, insert at the begin. So option is 2. So I want to insert the node 5. See, inserted. Let me display. So it is 5. So 5, 10, 20, 30, 40, 50. Now let me suppose I want to insert a node 25 between 20 and 30. After the third location, I want to insert the node. So inserting a node at any position. 3. Let me say I have entered 25. So let me check whether it got, sorry, enter the choice 3, sorry, enter the choice in, see, when I entered 25, it is a displaying invalid location. So other than 1, 2, 3, 4, 7. So enter your choice, insert the node at any position. So let me say I want to insert the node at any position. Now at position 3 only, I want to insert the node. So say 3. Now let the value be 25. So 25 value I am inserting at the location 3. Now let me check whether the 25 got inserted or not. So it is 5, 10, 20, 25, 30 and 40. So here what is the length? Length is 6. So let me check whether the length is coming 6 or not. So length of the linked list is 6. Now let me try to delete the node from the beginning. So when I try to delete the node at the beginning, so what should get deleted? 5 should get deleted. So first node I want to delete. So for that, my option is 6. The location value is 1. So first node should get deleted. So let me display and see whether the first node got deleted or not. No, I want to delete the node, third node, that is 25 I want to delete. So that my node will have 10, 20, 30 and 40. So delete 6th. So at a specified location I want to delete. So let me check. So I want to delete at third location, that is 23. So it got deleted. Let me check. 25 will get deleted. So it is 10, 20, 25 and 40. Now let me delete the last node, that is 40. So now see 6 and location is 4. Some enter the location. So here the location value what I have entered is something went wrong. Okay, so this is how we are going to execute the logic. Okay, that's all for now. Thank you. If you like this video, please subscribe to my channel and press the bell icon for latest notifications.